Hi there, this is Jacob Nash, Algebra Lessons, and this is Unit 6, Lesson 3, on transformations of square root functions. We'll look at transformation of cube root functions in Lesson 4. So, in case you don't know, Lesson 13, if you see right here, that was on transformations of the rational functions. Transformations, they just mean what can you do to the original function that can make it different? So remember, the original or parent function of this was y equals square root of x. So if we see this transformation equation, what's the difference? You can do something with a, you can do something with h, you can do something with k. Well, this should really just be plus or minus for here. I don't know why that's like that. Because you can add or subtract those things. So this is, if you remember, for the quadratic transformations that we looked at, we had those letters A, H, K, and they were in those spaces. So maybe you can remember what they would do for that, and it would do the same thing for this. But if you notice, when you have a square of something, it would look like this. But when you have a square root, it would only look like that. So it's like half of it. Well, not half of it, but basically just... there's not a mathematical term to put to that, but it's you can see how they're related. So let's look at what happens for certain things that could happen to A. If A is greater than 1, then we have what's called a vertical stretch. Oh, that's not how you spell stretch. So vertical stretch if you have that. But if A is in between 0 and 1, then you have a vertical compression. And if A is negative, then you have a reflection. A reflection over the x-axis. It matters which axis it is, because you'll see that there's one that can make it reflect over the y-axis too. So before we move on, let's see, what is a vertical stretch and compression? We've already talked about this a little bit, but what would this look like? A stretch is when, basically, if you have n over 1, it's just a number that's over 1. So it's, like I said, it could be greater than 1, but it also could be less than negative 1, depending on if A was negative or not. So it kind of, while it does what it sounds like, it stretches it out. So it would go from this to this. Like, oh, wow, stretched out. That's if it's a number that's over 1, and, well, over 1 in terms of if it was a fraction and if it's greater than 1. And compression is when there's 1 over a number. So that's in between 0 and 1, or it could be in between 0 and negative 1. Well, you would really say negative 1 and 0, but this is a compression, so it goes from this to this. It's like flatter. So that's what those mean. So let's see what could happen for x. If x is negative, that's the only thing we have. I mean, if it's positive, it's just normal. But if x is negative, then that means that we're going to have a reflection over the y-axis. That's what I was saying. Reflection over y-axis. And remember, I basically just mean reflection as it just goes over it. So for the negative a, if it reflects over the x-axis, this is the x-axis. So then instead of being like this, it's going to be like this. And if it reflects over the y-axis for negative x, instead of being like this, it would be like this. And if a and x both were negative, then it would be like this. So that's what that means. Okay, so let's see what things could happen with h. If you had x plus h, I mean, x could be negative, it doesn't matter. Okay, what just happened? Basically, if you have positive h, then you're going to go left h units. So we call it h units because whatever number h happens to be, that's how much you move left. Remember, this is kind of confusing. It might seem confusing that usually a negative is put together with the direction of left, but it is negative because you're finding x, and if you set x plus h to equal 0, then you would get x equals negative h, so it would end up negative anyways. That's why it's like that. And then if it's h is negative, then it would be right h units. So negative is right and positive is left. For up and down, it's the same. So you go, when k is positive, which k is just a number that would be outside of the square root, you go up k units. So that seems normal because usually we think positive up k units, and then down k units if it was negative. So that's what transformations we can have. It's pretty simple. You just have to look at this list and know what things are going to happen. So let's graph this equation right here that I have, and we can see what transformations we have. Okay, so we'll just write down the transformations that will happen. So let's label the things A, K, and H. Now occasionally there won't even be those there. That would just mean 0 for them. Or if A wasn't there, it would be 0 or 1. So this is, and that would just mean normal. If these are 0, it's just normal, the normal parent function. If A is 1, that's normal parent function. So that's A, this is H, this is K. So let's see, A is 2, and since 2 is greater than 1, we have a vertical stretch. So that's one thing, vertical stretch. Of 2. We have K that's negative 3, so that means right 3. And we have positive 1, so that means up 1. So those are the things that we need to do to the original points, which we talked about before. See, here are the original points. So if we have a vertical stretch of 2, that means that we need to do y times 2. So that's the first thing we need to do. Y times 2, because that's what happens, the y values change. And if we have right 3, that will mean when we go right 3, remember that meant that there was a negative 3. But that means basically that we need to have plus 3, because even though we had a negative 3 there, we need to do plus 3 for the y, because x, sorry. If that was what our values were, wasn't it? Right 3, yeah, so we need to add 3 to the x, and for the y, since it was up 1, we need to do this. So don't do x minus 3, because that's not That's not what it would be, even though that's what it looks like in the equation. So if we do these things, then we can figure out what the new points will be. So let's do the y's times 2 first. And you need to do the multiplying first before the adding or subtracting. So 0 times 0 is 0, 1 times 2 is 2, 2 times 2 is 4, and 3 times 2 is 6. So we did that. Now we need x plus 3. 0 plus 3 is 3, 1 plus 3 is 4, 4 plus 3 is 7, 9 plus 3 is 12. And then we need to add 1 to the y. So that would just be 1, 3, 5, 7. Oops. Didn't mean to do that. 1, 3, 5, 7. We changed that to that. So those are our points that we can graph to figure out what this would look like when it has a transformation. So we have 3, 1. So let's plot 3, 1. We didn't have any reflections, so it will still stay in the same quadrant as the original thing. We have 4, 3. We have 7, 5. And then I can't draw the last one, 12, 6, because doesn't go that far. So we can just draw those in. Well, actually, sorry, we still had 0, 0, didn't we? Oh, wait, no, never mind. That was 3, 1. Sorry. Whatever 0, 0 was, 0, 0 was just 0, 0, but it got changed to 3, 1. So that means that's our starting point. So sorry about that. Okay. So that means the domain range would start at 3 and 1, depending on the value. So that's what that was. But once again, let's just plot the original to see how exactly it changed. So the original would have a point here, it would have a point here, it would have a point here, and it would have a point here. So see how it changed. We had our vertical stretch. We can see that the black line that was the transformed one is pretty much, what would you say, like steep, kind of has a steeper slope. And then we can see that it moved to the right 3 and up 1, each point that we had. We can see from here, 1, 2, 3, 1. Oops. And then from here, 1, 2, 3, 1. Wait a second, what? Oh, wait, sorry. That doesn't work for everyone because of the vertical stretch. Sorry. So that would be it for this video on transformations of square root functions, and we'll see how it is for cube root functions in the next video.